Today I will.
Today I will.
Use multiplication.
Use multiplication.
To express equivalent measurements.
To express equivalent measurements.
To partner A, what do you think this learning target means? Tell partner B. Partner B, listening ears.
So 20 divided by 4 equals 5.
Class.
Yes.
I would love to hear what y'all have to say. Alexa, I heard you saying some beautiful vocabulary words. On the first day, we converted using a larger unit and making it a smaller unit. So who's bigger, a quart or a cup? The quart's bigger. So we would have went from the larger unit to the smaller unit. Who's bigger, the kilometer or the millimeter? The kilometer. So we would have gone from the bigger unit to the smaller unit. That was the first day, and we did pretty darn good on that, okay? Now, second day, yesterday, there were some struggles. But that's okay. That's okay. It's not the end of the year yet. Yesterday, what were we doing in class? We went from a smaller unit to a bigger unit. And I'm going to tell you, we had 6 masteries. That's okay. We got today. We got this. You ready? All right. I'm going to hand back your exit tickets. I want you to look at your exit tickets and see if you can use your resources on your desk to figure out what you did wrong. If you did not do anything wrong, then right here in this little white space, I want you to tell me what you did to get your answer. What process did you go through? How did you know to multiply by the number you multiplied, okay? Direct your attention to the Elmo. We're going to look at number 1, but I'm not going to tell you the right answer. I'm going to tell you my favorite no. It's going to be up to you to try to figure out why it is a no. Okay? You ready? This is my favorite no.
Oh.
This is my favorite no. So think about it real quick. I want you to tell me what I did that was not correct. What thinking, Jaren, did I do that's not accurate? Pair it back with your partner. Partner B. Tell partner A what you think I did wrong. Tell her why you feel that.
I disagree because 7 days supposed to be a period and it equals 1 week. And 7 days are a week. 105.
Okay. Class.
Yes.
Jerry said, "Ms. Prelow, I don't get what you did wrong." And I understand that because this was the number 1 mistake on yesterday's exit ticket, meaning most of you made this mistake if you made a mistake on your exit ticket. So please, somebody, a mod, help us out. Why is this a no?
Because you put 1 day equals 7 weeks.
Because I just wrote, and I'm gonna come over here and look. 1 day is 7 weeks. Think about that. Is 1 day equal to 7 weeks?
No.
I know that 1 week equals how many days?
7 days.
7 days. So I'm going to take my week and I'm going to cut him into 7 equal sized pieces. What does each one of these baby units represent?
1 day.
1 day. You're correct. That means this represents day what? Day 7 over here. But I only want 1 day. So I'm only talking about this 1 piece right here. So in reality, I'm saying that 1 day is equal to what fraction of a week, class?
1/7.
So I should not have written 1 day is 7 weeks. I should have written 1 day is equal to 1/7 of a week. What is 1 day in weeks, guys? What is 1 day in weeks?
1/7.
1/7 of a week. It's a fraction of a week. So what we're learning is, see, we already wrote the pattern that when we convert from a bigger unit to a smaller unit, we had to multiply by the whole number conversion factor. Let's come back and what are we noticing when we go from a smaller unit to a bigger unit? We're still converting, but what do we have to do in order to master it?
Go from a bigger number to a smaller number.
So your number is bigger at first, and your number
Get smaller.
gets smaller or decreases. So are you multiplying by a whole number if you're getting smaller?
No.
You're multiplying by a what?
Fraction.
A fraction or a...
Decimal.
All right, so when you're converting from a smaller unit to a bigger unit, you must multiply by the fraction or decimal. That is the pattern that we continue to use over and over yesterday. Every time we worked a problem, we were multiplying by a part of the larger unit. Remember, when we multiply by decimals, what are we actually doing? We're actually dividing. These are all patterns that you have told me over the past couple of weeks. We have to remember the patterns that we're developing to apply it to this new concept. Y'all, this standard, measurement standard, in order to do the measurement standard, you got to be able to know how to multiply and divide by powers of 10. Multiply multi-digit whole numbers. Multiply decimals and whole numbers. It's a lot of skills wrapped up into one lesson, okay? But we're going to keep pushing, we're going to keep persevering. Y'all ready to go? You're ready for problem solving. We've been doing the naked numbers, now it's time to put some meat on the bones, okay? So today I will solve multi-step word problems
Multi-step word problem
involving converting measurements.
involving converting measurements.
You can come down, Abigail. All right. Remember that when we are solving word problems, there's a process that we have to go through, okay? Liza's cat had 6 kittens. When Liza and her brother weighed all the kittens together, they weighed 4 pounds, 2 ounces. Since all the kittens are about the same size, about how many ounces does each kitten weigh? What's the main idea of what's going on in the story?
The main idea of the story is Liza and her brother are weighing all of her kittens together and see how much does they weigh and how much one kitten weighs.
I agree with you because Liza cat has some kittens and they weigh them and now they want to find out. And each kitten weighs about the same size and they're trying to find out how many ounces each kitten.
Liza's cat had 6 kittens. What do you think we should draw? A tape diagram. So how would I start that?
A
A box, a rectangle,
6 pieces.
and you want 6 units inside?
6.
6 units? I like that. 6 units on the inside. What does each one of these units represent, guys? One kitten. So I'm going to write that underneath. That each unit represents 1 kitten. Remember, our tape diagrams need to be labeled with numbers and words. All right, so pick up from where we chunked. You ready? When Liza and her brother weighed all the kittens together. Anything I can draw there? You're thinking that might be the hole right there? Let's keep reading, see if you're right. They weighed 4 pounds, 2 ounces. That's the total. So yes, we will draw our bracket and label it as 4 pounds, 2 ounces. You ready? Since all the kittens are about the same size, about how many ounces does each kitten weigh? So where's the question mark? You are correct. It's at the end of the sentence. But where in our model is the unknown? Each unit. So that is the unknown. And the unknown is the how much the kittens weigh. So the unknown is blank. I'm going to put OZ. Anybody know why I put OZ?
Ounces.
OZ, ounces. OZ stands for ounces. Partner A. Tell your partner how you think we should solve this problem. Go.
I think we should solve this problem by multiplying 6 kittens times 16 ounces because they want us to convert them into 16 ounces. So we multiply 6 kittens, we multiply 16 times 6.
Yeah, 16 times
I agree because you need to multiply. Because we know she got 6 kittens and
If 1 pound is 16
multiply.
ounces, what's 2 pounds?
And she wants to find the ounces. How much ounces each kitten weighs.
See how much each kid weighs.
I am curious to hear how we're going to solve this. Who wants to share? John Tripp.
16 ounces times 4 pounds.
So you think once I do 16 ounces times 4 pounds, my answer is going to be solved?
You gotta add 2 ounces to it. Wow.
Add 2 ounces to it, and that's going to tell
And then
me.
you gotta divide it by the 6 kids.
Oh, so I'm noticing that it's not just 1 step. It's not just 2 steps. It's actually a 3-step problem. Y'all ready to show that thinking on this paper? You told me the first thing I have to do is convert. And you told me I'm going to be converting by multiplying my
The 4 pounds.
4 pounds. I'm going to put 4 times
The 16.
16 ounces in each pound. And then you said after I do that, I'm going to do what?
Add the 2 ounces.
Add the 2. Guys, this is a multi-step problem. Do I need parentheses at this point?
Yes.
Why?
Because you have to multiply first.
Well, what are the orders of operations? What's the last step I need to do after I convert to ounces and add the 2 ounces?
Divide.
Divide by
6.
6. Solve on your own. You got this. Solve this on your own. Boys and girls in the back, you have about 3 more minutes, and then I'm going to need you to transition to the front. 3 more minutes, and I'm going to need you to transition to the front. So go ahead and try to wrap up whatever you were on. What you got as an answer? 11. I have 11 too. 11 what?
Ounces.
Does my answer make sense is what I'm trying to figure out. How can I check to see if my answer makes sense in the blank? I already have ounces, 11 ounces.
Do 11 times 6.
Yes, sir, Devontae. I could check my work by saying 6 copies of 11 should equal 66, right? 6 copies of 11. That's a math fact, right? 6 times 11 is?
66.
Does it check out?
Yes.
Does it work? So,
Yeah, put it in.
oh, you know what? Take out your highlighter.
Yeah, that's what I was.
Yep.
I was going to. You gotta put it in.
Did I write my answer in a complete sentence?
Yes.
No, you didn't.
I did it. So can I give myself an A?
No.
Nope, I have to plug it in first. The answer is
11.
11 ounces. Now I can plug it in.
Oh, because it says each kitten.
Each kitten.
You can't put 66 because that's the total of all of them.
You got it, girl.
That's all kittens.
You got it. All right. B. Did I draw and label a model that represents the prompt?
Hey, I write 11 in each of them, in each part.
Nope. remember, if it's equal size parts, then you just gotta put it in one. All right, now what?
Did you write an equation of the variable to represent? Yep, I did. No, I didn't.
So I didn't. So right now I got it in, what is this called?
Equation.
It's not an equation. It's a expression. I need to make it an equation with the unknown represented with a variable. What variable I want to use?
K.
Sweet. K for kittens. Now I can tag my C. Did I check my work to make sure my answer is reasonable? Right there. 6 times 11 is 66. All right, guys, I'm going to tell you, some of these problems are very challenging, okay? But that's okay. We're going to persevere. That's why we're not working independently. We're going to be working in teams of 2 or 3. So I want you all to pick up all of your stuff and continue working through the problem set. What are these called?
Tape measures.
Tape measures. What do they show us?
Centimeters, millimeters, and meters.
So on one side they show U.S. customary units, and on the other side they show metric units. I want you to, with your partner, show me a meter using your tape measure. Go. With your partner, show me 1 meter.
1 meter. From 1 centimeter all the way to 100 centimeters.
How did you know how big a meter was, Shomar?
Because a meter is if you count these guys right here, that was 1,000 of those.
Oh, he says a meter is 1,000 of these little bitty guys.
And the white and the black part, the white part and the black part is 10,
It's 10 of the whites and black parts,
and it makes a meter.
and it makes a meter. Okay. Guys, think about something in this room. Look around. Do you see anything in this room that's about a meter? What? Okay. It's a little bit bigger, but it's about a meter. So the Promethean board's a little bit bigger than a meter. This board over here, they're the same size. Okay. Anything else, Brendan?
The door?
The whole door?
No, like. Yeah.
Look at that. From the doorknob to the ground, it's almost a perfect meter. I wonder if they did that on purpose. So let's think about what things we can measure using a tape measure. Using a meter. What is something that you think we could measure using meters? The what? A desk. A desk we can measure using meters. Okay, he's a little bit smaller than a meter, so he would not be a whole meter. He would be a not a half. A half of a meter would be over here. He's a
meter?
How about we just say a fraction of a meter? Okay. Yes? The wall. So I can measure the length and the widths of these walls, right? So those are all things we can measure with meters. Here's what we need to do. Find 1 centimeter on your tape measure. 1 centimeter. What side should you be on?
The black.
The black and white side. What's the other side?
US.
And it's going to be measuring what?
Inches.
Inches and feet. This is the metric side. Why does Ms. Prelow love the metric units?
Because they're powers of 10.
Because they're powers of 10. And what do we know about powers of 10? Think. What do you know about multiplying and dividing by powers of 10? Valerie. When I multiply by a whole number power of 10, I shift to the right, I get smaller. I shift to the left and I get bigger. I increase in value when I multiply by a whole number power of 10. What about when I divide by a whole number power of 10? The value decreases in size. I go to the right. What about if I multiply by a fractional power of 10, like 1/10 or 1/100th? If I multiply by a 10th or a 100th, what'd you say? I am decreasing in value. That's something I need you to think about today. When we multiply by a fraction, we actually get smaller in value. And you showed me this 2 weeks ago when we were multiplying decimals, that when you multiply by a 10th, class,
Yes.
when you multiply by a 10th, you are decreasing
A one place value.
one place value. If you multiply by a 100th, you are
Decreasing two place value.
decreasing two place value, shifting to the right 2 times. Remember, this lesson is all about taking everything we've learned in the past and mixing it all up and put it in the paper, okay? You can't forget the old things that we've learned. Can't do it. All right? So let's look at the first problem. It says there are blank centimeters in 1 meter. Can you show me 1 centimeter? Any centimeter. I don't care which centimeter. Show me one on your. You should take. That's still it again. How big is 1 centimeter? About how big?
10
A
millimeters.
fingernail. The thickness of the fingernail or the width of the fingernail? The width of the fingernail. How many of these centimeters are in 1 meter? How many of these fingernail widths are in the meter?
10.
Oh, there's 10? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh,
That's a meter?
that's a meter?
No.
No, that's why we're doing this activity. I love it. Thank you for saying that, but that's not right. It's okay though. Thank you. This is 10 centimeters. Is this a meter? No. This is only a fraction of a meter. I said how many centimeters are in a meter? How many centimeters are in a meter?
100.
I need you to add that. There are 100 centimeters in 1 meter. Five, 4, 3, 2, 1. Find 1 millimeter. Any millimeter you want to. Find any millimeter that you want to. About how big is the millimeter?
1,000.
Y'all ready? How many millimeters are in the meter?
1,000.
Write it. Ooh, how many millimeters were in the centimeter?
10.
Write it. Check your conversion charts. Check your conversion charts and make sure what we wrote was accurate. Just put a check next to it. Was there a millimeter to centimeter conversion?
Yeah.
There is? Okay, good. Were we right?
Yeah.
All right, so can I show you a kilometer using my meter stick?
Maybe.
I can show you a kilometer.
No.
How big is a kilometer?
Huge. You say from right here to all the way to Legacy Oak.
So from the Legacy Oak sign outside all the way to the EA Spartan Stadium, that is about 1 kilometer. Okay? Can I measure that using one of these?
No.
No, this is way too small, right? Use your conversion factor to see how many of these, nope, how many of these make up 1 kilometer.
1,000.
Use your conversion factor sheets.
Yes.
So I see that I have it's kilometer or kilometer, whichever one you want, is equal to 1,000 meters. So look at part B. It asks you to use your conversion chart to determine how many meters are in a kilometer. We're not using the do what, guys. Come on. What do I need to do? Use. What do I need to use? I heard somebody say determine. Determine is another do word, action word. word. Determine what?
How many meters are in a kilometer?
Did you use your conversion chart? Yes. Did you determine how many meters are in a kilometer? Yes. How many? 1,000. Y'all got it going on. Now, we're going to do this real quick. Who's bigger? Oh, first, we're going to do what? You ready? Reason about the size of each unit by answering the following questions. What are we going to do? We're going to reason. It's not an asking word. Do you know what reason means? Use your brain and math thinking and your understanding to answer these questions, okay? That's what it means to reason about something. So what are we going to reason about?
The size of each unit by answering the following questions.
All right, we need to tell which is bigger. We need to tell which is bigger. We need to tell. We need to tell. I know I'm going fast, but we want to make sure we finish, right? What do we need to tell? Which unit is bigger? And you can go ahead and do that for all these questions because it's the exact same question.
So all of them the same answer.
I want partner A, that partner on this side of the room, to turn to their partner and say which one they think is bigger, a centimeter or a meter, and why. Go, partner A.
The meter is the one that have the bigger unit, but you have to, like, if you have a bigger number, that means that your other thing going to be, if you have a bigger, like, a meter's big, so.
Partner B, do you agree with what partner A said? If you do agree, you're going to restate what they said. If you disagree, tell them why. Go.
I don't really understand what you're trying to say. But I sort of agree with what I'm trying to say because I know that a meter is bigger than a centimeter. I agree with that because it takes 100 centimeters to equal 1 meter. So if centimeters were bigger than 1 meter, how is it another centimeter? So I do agree with what you're saying, but I just didn't really understand how you're going to explain how it works.
Who's better, the centimeter or the meter? Meter. So we're going to write 1 meter. How did you know, Zanaria? If it takes 100 of these little bitty guys called centimeters to equal
one big meter.
one of these big guys, obviously the centimeter is the smallest unit, making the meter the biggest unit. I like your reasoning. I liked it, okay? That's that math thinking. I love the way you brought in what we learned, the conversion chart, okay? Can anyone tell me what you were doing in class today? What was the main thing that I had everybody in this class working on? Kirsten.
Probably just multiplying the express equivalent fraction or decimal.
Everybody in here was multiplying to express equivalent measurements. Can anybody tell me when do you multiply by a whole number and when do you multiply by a fraction? Raise your hand. Alexia, you disagree with what Tristan said. He said when I go from a small unit to a large unit, I multiply by a whole number. Why do you disagree?
Because when there's a new converted from a bigger number to a smaller unit, you must multiply by a whole
To the board. When do I multiply by the whole number?
You convert it from a bigger unit to a smaller unit.
Bigger unit to the smaller unit, we need to multiply by the whole number. And it makes sense because the bigger unit has smaller numbers, the smaller unit's got bigger numbers. So if you want to make the numbers bigger, you gotta multiply.